What's up everybody, this is John with John Vet Innovations bringing you another math lesson. If you do enjoy this video, make sure you hit that like button, leave a comment on maybe another math topic you'd like me to tackle. And if you really enjoyed this video, do make sure you hit that subscribe button because it really does help out the channel. So for those who have done that, thank you so much for your help. Explain how to use the quotient rule. This is more of when you would actually use the quotient rule for very complicated functions that have say your variable, most often used as x that we use. So you would have functions of x on the top and the bottom of your fraction. You would have x values in your numerator and your denominator. In this case, what I want to show you is what happens if you don't have an x value on, say, the top of your fraction. Like, does that change whether you can use the quotient rule or not? Not a very typical way that you would use the quotient rule, and a very excessive way to do derivatives, but maybe you are just curious of what happens if maybe you accidentally use the wrong rule, if you use the quotient rule in this case. So we've got here the function of y equals 5 divided by x squared. And if we use the simple number rule of derivatives, we can rewrite that as 5 times x to the power of -2. And then when we find derivatives in this format, what we do is we take our power value, which is -2, and we multiply it by our factor. In this case, it's 5. So that would be -2 times 5, which would give us -10. And then we subtract 1 to our power value. So -2 minus 1 would give us -3. Leaving us with -10 times x to the power of -3, or -10 divided by x cubed. Now, if the quotient rule works for this value, for this function, then we should get the exact same value. So let's try it. So in this case, we're going to use the same principles. So our numerator is going to have our u value, our u function. So in this case, u is going to equal 5, and then the derivative of u, well, anytime we find the derivative of something that doesn't have a variable, or it doesn't have a variable represented by what we're deriving, in this case x, then that's going to equal 0. So our u derivative is going to be 0. Our v is going to be represented as x squared, so our v derivative is going to be 2 of x. And now what we can do is we can plug into our formula of v multiplied by derivative of u minus u times the derivative of v divided by v squared. And that's going to leave us with x squared multiplied by 0 minus 5 multiplied by 2 of x, all divided by x squared to the power of 2. And now we can start to simplify that. Well, x squared times 0 is going to give us 0, and 5 multiplied by 2 of x is going to give us 10 of x, and x squared to the power of 2 is going to be x to the power of 4, based on our indices rules. When we take a power of and we take that to another power of, so in this case squared to the power of 2, we just multiply those two numbers. So 2 times 2 would give us 4, so x to the power of 4. And now we can simplify it. Well, 0 minus 10 of x is going to leave us with -10x. And then on the bottom of our fraction, our denominator, is going to be x to the power of 4. So that'll leave us with -10x divided by x to the power of 4. And we can simplify this as both sides have an x. So we can divide both sides by x, which is going to leave us with -10 divided by x to the power of 3. So we end up with the exact same value, but obviously this is a much more complicated and unnecessary way to solve it. But if maybe you're trying to solve it and you get stuck and you remember this rule, but perhaps you have gone a bit blank on some of your other rules, this will still work for you. Well, hopefully you enjoyed that. Let me know if there is another math topic you'd like me to tackle, but always stay safe, be kind to one another, and I'll see you next time.